Let's start by evaluating cosine inverse of the square root of 2 over 2. When evaluating inverse trig functions, we're thinking about what angle do I plug into cosine to get out the square root of 2 over 2? Well, there's actually a lot of different angles that we can plug into cosine and get out the square root of 2 over 2. So there are special restrictions because for a function, we can only have one output. So we restrict the answers specifically for cosine inverse to be from quadrants 1 and 2, or actually more specifically, to be between 0 and pi. So we're thinking, what angle do I plug into cosine to get out positive rad 2 over 2? That has to be something over here in quadrant 1. And that's where this table can be really handy. I can simply look at the cosine column for the output radical 2 over 2 and trace it back to determine that the input angle was pi over 4. So cosine inverse of the square root of 2 over 2 is specifically the angle pi over 4. Now let's evaluate arc cosine of -1. Arc cosine is simply alternative notation for an inverse function. So this is the same as cosine inverse of -1. Well, cosine inverse, as we said, is restricted from 0 to pi. Since this is a negative value, my answer is going to have to come from over here on the left side of the y-axis. So we're trying to think, what angle do I plug into cosine to get out -1? And so this table, right, doesn't have a -1 out as an option. I have a positive one, and that corresponds to the angle 0. And so that angle 0 is the coordinate point 1, 0. So the answer is actually over here on the opposite side. The answer is pi because this coordinate point is -1, 0. So the angle that you substitute into cosine to get out -1 is pi. Now let's evaluate arctangent of radical 3, which means tangent inverse of radical 3. So what angle do we plug into tangent to get out radical 3? The restriction for tangent inverse is different than cosine inverse. The restriction on tangent inverse is that my answers have to come from quadrants 1 and 4. But in quadrant 4, the answers have to be the negative versions of the angles rather than the positive version. So a very specific restriction on tangent inverse. So what angle do I plug into tangent to get out radical 3 in either quadrant 1 or 4? Well, it's going to have to be quadrant 1, where tangent is positive, and that means that I can reference this table again. So I can look at the tangent column, find the output of radical 3, and recognize that it came from an input angle of pi over 3. And now let's evaluate tangent inverse of -1. So we're trying to think about what angle in either quadrant 1 or 4 do I plug into tangent to get out -1. So my answer is going to have to come from quadrant 4 because the output here is negative. So is this table going to help us? Well, this table really represents angles between 0 and pi over 2. But what's nice is that because we have to use the negative version of the angle down in quadrant 4, this table is actually going to be helpful for us when evaluating tan inverse and actually sine inverse as well, because that's the restriction on sine inverse is pretty much the same as tangent inverse almost, is going to be quadrants 1 and 4 and then the negative versions of the angles from quadrant 4. So how can we still use this table even though these angles are from quadrant 1? Well, I'm going to look for the output of 1 down the tangent column and recognize that it came from an angle of pi over 4. But since the angle has to come from quadrant 4 in the negative direction, I can simply put a negative in front of the angle. So the answer here is going to be -pi over 4. So again, cosine inverse comes from quadrants 1 and 2, where if the answer has to come from quadrant 2, we have to think about it a little bit more. If I'm doing a sine inverse or a tangent inverse, my answer has to come from quadrants 1 or 4. And I can use this table and find the output, map it back to the input angle, and if the answer had to be from quadrant 4, then I would simply make the answer negative of that angle for sine inverse and tangent inverse.